Now that you're watching this video, you should go to your Canvas page and open up 9.1.3 Volume and Surface Area of Prisms. So here we have a rectangular prism, and next to that rectangular prism we have two different nets. Again, what a net is it's just a two-dimensional representation that when folded along the dark lines will fold into a three-dimensional figure, which is the prism. Now let's take a look at this prism and see if we can find the volume and surface area. If we want to find the volume, what we need to do is first of all identify what do we call the base. In a rectangular prism, any of the two faces that are opposite each other can be considered the base. For this problem, let's consider the top and bottom to be the base. So if I highlight this, this will be the base up here. Now the volume of any prism is just the area of the base, which we say is a capital B, times the height. Now the height is just the distance in between the two bases. So if I want to find the area of the base, there's really two ways I can do it in this diagram. I can just count the number of squares on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 of them, so the area of the base is 12. Then I need to multiply that by the height. So I'm just going to count 1, 2, and it's 2 units high. So when I multiply that, I'll get 24 units cubed. Now instead of counting out all the squares, I could also just use the formula for the area of a rectangle. If I count this side here, I have 1, 2, 3, 4 for the width, and 1, 2, 3 for the length. Or you can call them base times height. And you can just take 4 times 3, which is equal to 12. So that's just another way of getting the area of the base. Now, for the surface area, what I want to do is, first of all, find the area of the two bases together. Well, I already found the area of the base when I was doing my volume formula. That was 12. And since there's a top and a bottom, that's also going to be 12. The next thing I'm going to find is my lateral surface area. To find the lateral surface area, we're going to do the perimeter times the height. Now, this height is the height of the prism, and the perimeter is the perimeter of the base. So to find the perimeter of the base, this side is 4, 4, 3, and 3. So I just add together the lengths of all the sides of my base. In this case, 4 and 4 is 6, plus 4 is going to be 10, plus another 4 is going to be 14. So my perimeter is equal to 14. The height is equal to 2. So my lateral surface area is going to equal 28. So really what I did is I took 4 times 2 here, I took 3 times 2 here, 4 times 2 for this one and back, and 3 times 2 for this one and back there. And I added them all together. Instead of doing each one of those sides individually, when you do the perimeter, you're just doing them all at once. Now, if we have the area of the bases together is 24, the area of the lateral sides are going to be 28. So to find the total surface area, I'm going to add those two together, and that will give me 52 units squared. The problem we were just working with was a rectangular prism because the base was a rectangle. This here is an example of a triangular prism because the bases are triangles. In a rectangular prism, we said that any of the two opposite sides could be considered the base because they're congruent and parallel. But in a triangular prism, there's only one pair of sides that can possibly be the base, and that is the pair of sides that is congruent to each other and parallel to each other. So in that case, it's going to be the triangle on top and the triangle on bottom. Now notice that most of the time when you see the dotted lines, those are lines that would be hidden from a normal view because they're behind other parts of the prism. So here's another picture of the three-dimensional version of the triangular prism and another net of the triangular prism. If you want to try drawing one yourself, they are a little bit tricky, and I'm not very good at it myself, but I'll go ahead and give it a shot. Basically what you do is you try and draw one triangle below the other, and all the hidden lines have to be dashed. So this is going to look something like this. And then this line here would be hidden, and then that one's not, and that one's not there. So it'll look something like that. Now, I know this isn't a very good drawing of that, and some of you will be very good at this, others will not be as good, but just will help you sometimes drawing diagrams to be able to label different sides, and that might be helpful in the problems. So now we're going to take that triangular prism and we're going to see if we can find the surface area of that prism. So the first thing I want to do when I'm looking for surface area is find the area of the bases. So in this case, my base is a right triangle. In a right triangle, I can find the area is equal to base times height divided by 2. Now, this is a small b because it's the base of a triangle, which is a length, not a capital B, which stands for the area of the base. So if I do this, because this comes at a 90-degree angle here, I can call either the 5 the base or the height, and then the 12 the base or the height. Doesn't really matter which is which. So this will be 5 times 12 divided by 2, so that will be 30. So that's just the area of one base is 30. The area of the other base is 30 as well. So that's going to be a total of 60 for the area of the bases. When I look at my map plan, that means that this one's 30 and this one's 30. So now let's try and find the lateral surface area. Before we talked about the lateral surface area just being the perimeter of the base times the height. And when you do that all at once, really what you're doing is just finding the area of each one of the lateral faces, and you're just doing it in one step rather than having to do it in 3 separate steps. To find the perimeter though, if I know this is 5 and this is 12, I'm going to need to use the Pythagorean theorem to find the hypotenuse. So let's do that right here. I'm just going to call this C, and that would be 5 squared plus 12 squared is equal to C squared. So 25 plus 144 is equal to C squared. 169 is equal to C squared. If you do the square root of both sides, you get that C is equal to 13. So now I need to find the perimeter. Remember, the lateral surface area is the perimeter times the height of the prism. So the perimeter will just equal 5 plus 12 plus 13, and then you multiply that by the height, which is 19. So when you add those together, 5 plus 12 plus 13, you get 30 times 19. And when you multiply that together, you're going to get 570. So to find the total surface area, you're going to add the area of the bases, which is 60, plus the lateral surface area, which is 570, and that will give you a total of 630 units squared. And now we're going to find the volume of the triangular prism. This is the same prism we just used. So remember, volume is equal to the area of the base times the height. In order to find the area of the base, in this case, since it's a right triangle, we need to do base times height divided by 2. So the area of the base is equal to base times height of the triangle divided by 2. So that's 12 times 5 divided by 2, which will give me 30. So the area of the base is 30 times the height, which is 19. So I need to take times 19, and that's going to equal 570. And that will be units cubed.